Hi, welcome to MyProjectBazaar.com. Now let me discuss about the title of the process. Our title of the process is kNNVWC, an efficient k-nearest neighbor approach based on various with clustering. The main objective of the process is to introduce the two main parts of kNNVWC, the various with clustering part and the exploitation of triangle inequality to efficiently find kNN for a query object at a reasonable cost throughout the partitioned clusters. Then now let me discuss about the abstract of our process. This work presented a novel nearest neighbor approach based on various with clustering called kNNVWC. This approach is able to produce compact and well separated clusters from high dimensional data of various distributions. The quality of a decomposition resource has maximized the efficiency of using triangle inequality to prune unlikely clusters in searching for kNNs. The proposed algorithm shares efficiency feature in producing less overlapping clusters with non-binary partitioning techniques, and meanwhile its clustering time is as fast as that of binary partitioning methods. In the experiments, 12 datasets which vary in domain size and dimensionality have been used. The experimental results have shown that kNNVWC has demonstrated promising and stable performance comparing to 7 algorithms. This is a completed abstract of our process. Now let me discuss about the data flow diagram of our process. First, our process starts with itself dataset selection. So here we are selecting the dataset as a diabetes dataset. In this we have 9 attributes. They are a pedigree level, insulin level, serum level, and body mass index and class labels. In the class labels we have zeros and 1 values. The 0 1 predicts 1 predicts the malignant and 1 predicts benign. After the data has been selected, we have to load the data into the database. Then we have to partition the data by using thumb threshold. After we partition the data, we have to cluster the data, and after we cluster the data, we have to estimate the distance between the between the objects. After that, we have to estimate the nearest neighbor results by using some distance calculation. After that, by using that distance estimations, we predict exact results based upon that particular distance. Finally, we evaluate the performance of particular proposed system and existing system by using time efficiency parameter. This is a complete data flow diagram of our process. Now let me discuss about the demo of our process. First, you have to run home.java. Just right click on that frame and click run file. The home page will open here. So our title is kNNVWC, an efficient k-nearest neighbor approach based on various best clustering. Then click next button. Here the dataset selection process will be here. So click browse button. Here we have to select the dataset for our process. Choose dataset. Here we are selecting the PIMA diabetes dataset. Then click load. Datums are embedded into the database. Then click next. So here we partition the data. Data has been partitioned. Here we are partition the data based upon the class variables in the dataset. Here we are partition the data as a partition 1 and partition 2. Then click next. Here we are merging the data based upon the partitions which we are splitted. Then here we cluster the data by using parameter and attribute called age. By using that age attribute, here we cluster the values cluster 1, cluster 2 and cluster 3. Then click next button. So here we predict the size of the clusters. Here just click predict size. In that here we have a cluster 1 size, cluster 2, cluster 3. These are the things which denotes the count values of that particular cluster 1, cluster 2, cluster 3. Then after that we have to estimate the distance. So click estimate distance. Distance has been estimated by using the exact attributes of the diabetes. Here we are using n times glucose level, blood pressure, skin and serum level. By using the type of informations, here we are calculating the distance value. The distance value has been calculated based upon these parameters. Then after that, here we predict the results based upon the distance. So here predict that particular results is normal or abnormal results. Then by using that, here we are going to classify that particular results, normal results and abnormal results. Then estimate the evaluation parameters. So just click estimate button. Here we are having a start time, end time and execution time. These are the parameters of a time which are in milliseconds. So after that, by using these parameters, we evaluate the performance of proposed system and existing system. Time efficiency of the proposed system is high and the existing system is low. Through this we can achieve the efficiency of the system. This is a complete demo of our process. Thank you for watching.